our first section of Chapter 8 is 8.2, so we're going to get the graphing out of the way. But Chapter 8 is a lot about rational expressions. So we're going to basically pick up where Algebra 1 left off with rational expressions. So we're going to add, multiply, divide, simplify, solve, and graph rational functions. So a rational function would be something like, well, a rational expression would be something like this. All right, so if you remember that from Algebra 1, you're in good shape. So that's basically a rational function, or a rational expression. Rational functions is what we're going to graph, and we're just going to graph these simple ones. So that's kind of nice. But yeah, so we have an irrational function is just one polynomial called p of x over f of x, or g of x, okay, where p and g are polynomials. So that's pretty much all you need to know. So what it looks like, let's see, let's figure out what it looks like. So the most basic rational function you can do is we can do y equals 1 over x, okay? That is a rational expression. So if we don't know what something looks like, let's go ahead and make some xy chart. So let's see, 0 would be, maybe we could try 0, we could try 1, -1, 2, -2. So if I plug in 0, 1 over 0, that's not going to work. That is undefined. So we have our first asymptote at x equals 0. So here's my xy chart. My asymptote I'll plot in blue. So x equals 0 is just the y-axis line. That is our first asymptote. So our graph is not going to cross that. All right, so let's try 1. So I plug in 1 over 1. That's 1, so that's okay. 1 over -1 is equal to -1. We've got 1 over 2, which is 1/2. And then 1 over -2 is -1/2. So let's see what that looks like. So when I graph it, I've got 1, 1, -1, -1. We also have 2.5. So right about there. -2 and -1/2, right about there. No, right about here. That looks right. All right, let's see. And there's one more asymptote actually. And let's see, can we get, if I plug in 0 for y, what is x going to be equal? So if I cross multiply, I'm going to get x equals 1. Actually, I'm going to get 0 equals 1. So 0 times x is 0. That is also no solution. So I have another asymptote at y equals 0. So here's my other asymptote. So rational expressions have two asymptotes, right? One where it's y equals 0, and eventually that will be k. And the other one is at x equals 0, and eventually that's going to be what letter? H. Good job. All right, our friends are going to come back. So remember that graphs get really, really close to the asymptotes, but they never touch it. So you get, here's my 2 points. It's going to get really, really close to x equals 0 and really, really close to y equals 0. So you have this kind of half circle thing. And then upstairs, it's going to have here's my 2 points, and it's going to get really, really close to y equals 0 and really, really close to x equals 0. So, and that's your basic rational expression. So you want 2 points to, you want 2 points to the left of your x equals 0 or h asymptote. So you need 2 points on this side. So 2 points, and so we picked this point and this point. And then you need 2 points on the left, 2 points on the right. Stand up, sit down, fight, fight, fight. All right? So 2 points on the left, 2 points on the right of your vertical asymptote, and then you've got your graph. Right? Once you have those 2 points, you're going to graph it. You're just going to get super, super close to each asymptote, and that's it. So for our domain is going to be all real numbers except what can't x be? 0. Good job. So accept x equals 0, and later on that will be h. And then our range is going to be all real numbers, except y equals, in this case it's 0. Eventually that will be what letter? K. Good job. So whatever number k is. All right, so that's our basic one. And then here's what you know from here is just basically what we did on the first slide. It's a lot more fun to create the graph ourselves rather than just look at one. So the parent graph is 1 over x, but any form is going to look like this. So we have a over x, so we could graph something like 6 over x. That would also be the same idea. All right, and when we need 2 points to the left, 2 points to the right of the vertical asymptote. So write that down, that's important. Sometimes people get messed up. So to graph. All right, so let's see, we're going to, if you're a step person, write it down. If you want to get credit for the notes, write this down. So to graph, draw the asymptotes. Okay, that's the first thing. Now that we kind of know what they are, so draw the asymptotes, which is going to be x equals 0, and later that's going to become h when our friends come back, and also y equals 0, and later that's going to be k. Right, that's our first step. And then now we're going to pick 2 points, or not 2 points, 2 x's, 2 x values. 2 x values to the left of the vertical asymptote. All right. So pick 2 x values to the left of the vertical asymptote. Oops. All right, so that's the up and down one. So pick 2 points to the left of that, and pick 2 x values to the right. All right, if you remember those 2 things, you'll be in good shape. And then secret step 3, domain is going to be all real numbers, except x equals 0 or h later. And the range is going to be all real numbers except y equals 0. And later that will be k. Okay, so write these 3 steps down so you can get credit for your homework, but if you keep that in mind, you'll be in good shape. Okay. Okay, so let's move on to our next example. We are going to do y equals 6 over x. We can compare it later. We don't need to do that. All right, so let's see. So we're going to draw our asymptotes. We don't have any h or k currently. We'll find out about that later. So our asymptotes, step 1, are at x equals 0 and y equals 0. So basically the x and y axis. All right, so when we draw that, we've got this one, we've got this one, and then we want 2 points to the right and 2 points to the left. Okay, so basically, since x is at 0, we want 2 negative values and 2 positive values. So we can pick 1 and 2 and -1 and -2. Doesn't really matter as long as we have 2 points to the left of x equals 0 and 2 points to the right. Not sure if I mentioned that. All right, so when we plug it in for y equals 6 over x, we have 6 over 1, which is 6. 6 divided by 2 is 3. 6 divided by -1 is -3, -6, JK. And 6 divided by -2 is -3. All right, so when we graph those, we have 1 and comma 6, so way up here somewhere. positive 2 and 3. We have -1 and -6, 2 and -3. And then you have these random points, but remember that these 2 points are going to get really, really close to the asymptotes. Okay. So when you graph it, it gets super, super close to both asymptotes. So it goes like that. It doesn't cross them. The points down here get really, really close to the asymptotes. Okay. So there they are. And then our domain is going to be all real numbers except x equals 0. And our range is going to be all real numbers except y equals 0. Okay. So if you have any questions, write them down, and I'll ask me in class tomorrow. Right, so you try this one all by your lonesome. You can do this. Y equals 3 over x. If you can do this one, you're in good shape for H and K because they're coming. So all by your lonesome, go for it. And then check back with me later. Hopefully you can fast forward this part. All right, so our asymptotes are at x equals 0 and y equals 0. Graph those. Okay. So this down here is x equals 0. This is y equals 0. Right. And I'm going to pick 2 points to the left and right. Right. So I can pick positive 1 and 2 and -1 and -2. Doesn't really matter as long as I have 2 points on the left and 2 points on the right. So this will be 3 over 1, which is 3, 3 over 2, which is 3 halves. This will be -3 and 3 over -2. So if you like decimals, that's -1.5 and 3 over 2 is positive 1.5. So when I graph those, I have 1, 3, 2 and 1.5, 1 and -3, and 2 and 1/2. And remember, they get really, really close to both asymptotes. They give the asymptotes a big hug. Right. And then our domain is going to be all real numbers except x equals 0. And the range is going to be all real numbers except y equals 0. All right, so if you did that all by yourself, great job. All right, now our friends are back. So H and K. So we've got, if you look up here, we've got y equals a. So a is on top, and then x minus h. Remember, h is always the best friend, the BFF. So h is closest to the variable, and then k is on the outside. So h is in the denominator, k is on the outside. So very similar steps. We're going to draw the asymptotes. X equals h and y equals k. So if you could write that down, that'd be great. And then we're going to plot points to the left and to the right of the vertical asymptote. That sounds familiar. And our vertical asymptote is going to be at x equals h. All right, so 2 points to the left of that number, 2 points to the right. And then we're going to draw the 2 branches. So in plot points, you can plot 2 points to the left and 2 points to the right. And then our domain is going to be all real numbers except x equals h. And our range is going to be all real numbers except y equals k. All right, so pause that, write that down, and then we'll do some problems. Okay. So we've got this one. We're going to graph this one and then state the domain and range. So let's see, h is always opposite again. So h is going to be -2. So here's our vertical asymptote. Okay. K is same direction, so that is going to be -1. And so there's our other asymptote, our horizontal asymptote. X equals -2 vertical, and then K is the horizontal asymptote. Because when you graph those lines, if you remember from algebra 1, here's where x equals -2 is here, but it's also here and here and here. So what happens is you get a vertical line through x equals -2. And then y equals -1. Well, here's y equals -1, but it's also here and here. So you get a horizontal line. Okay, so there's our two asymptotes. And now we want to pick 2 points to the left of -2 and 2 points to the right. And we're not going to be shifting. We're just going to plug it in directly. So if fractions are not your friend, they will be your friend after this. So 2 points to -2. Again, it really doesn't matter what we pick. We can be a little more strategic about it and not get fractions, but it doesn't matter. You just need 2 points to the left and 2 points to the right. So we can plug in -3 and perhaps -4, and that would be 2 points to the left of x equals -2. So when I plug that in, I'm going to plug it into the whole thing. So we have -4 and then -3 plus 2 minus 1. And so when I work that out, that's going to be -4. -3 plus 2 is -1 minus 1. So when I simplify that, that's going to be +4 minus 1, which is equal to 3. Okay. And then my next one, I'm going to work this one out. So -4, -4 plus 2 minus 1. Don't forget about the minus 1. So order of operations, we have -4 divided by -4 plus 2 is going to be -2 minus 1. So -4 divided by -2 is a +2 minus 1, and we get 1. Okay, so those were 2 points to the left. Now I want to pick 2 points to the right. All right, now I want 2 points to the right. So, and then 2 points to the right. If you look at -2, I could pick -1, 0, 1, 2, 3, any 2 points to the right. So I'm going to pick -1 and 0. All right, so when I plug those in, let's see, I have -4 divided by -1 plus 2 minus 1, which is the same thing as -4. -1 plus 2 is +1 minus 1. And if you can get all these points by your lonesome, that would be really good. So -4 divided by 1 is -4, minus 1 is -5. Okay. And then go, if you can get 0 by yourself, go for it. We have -4, and then we have 0 plus 2 minus 1. And then we have -4 divided by 2 minus 1, which when we simplify that, we get -2 minus 1, which is -3. So we have all our points. We have 2 points to the left and 2 points to the right. So when I graph -3, 3, so we're up here, that's going to be right here. And -4 and 1 is going to be right here. And then I have 2 points to the right. So -1 and -5 is it should be below the other asymptote. So right here. And 0, -3 is going to be right there. So when I draw my points, I'm going to draw them through the points and then give the asymptotes a big hug. So get super close to both of them. So same thing with here. It's kind of hard with all this work in the way, but that's my other graph. All right, so now we have just our last thing is domain and range. So our domain is going to be all real numbers except x equals, what was h again? Good, -2. And our range is going to be all real numbers except y equals what? Good, k, -1. Good job. All right, so let's see, that's that one. This one, you try it all by yourself. Okay, I'll get you started, but I'm not going to finish it since we have a whole nother section to go. But our asymptotes are going to be, let's see, h is going to be x equals 2. and k is positive 1, so y equals 1. So 1 asymptote, so here's x equals 2, and here's y equals 1. Okay. All right, so you want to pick 2 points to the left of 2 and 2 points to the right of 2. So do that all by your lonesome, and I'll check that in your notebook tomorrow. And then here's the guided practice. So let's see, we have number 1, no h and k. What's h for number 2? 0, good job. K is -5, and then for number 3, we have both our friends. Okay. All right, for the next section, last one, will be as complicated as it gets for you guys. We're going to graph 2x plus 1 over x minus 3. And we're actually going to change it into a form we already know. So we're going to go ahead. We know how to do the long division for polynomials. So we're going to do x minus 3, and then we're going to put 2x plus 1 in the box. And then x times what equals 2x? 2. Good job. So then I'm going to multiply. All right, multiply, so we get 2x minus 6, and then when we subtract, remember we change the sign, so minus and a plus sign, and that's all we can do. So we have 2 and with a remainder of 7. So how we write that when we're long dividing is we have 2 plus our remainder over what we divided by, which looks similar to what we just did. If we change that around and put the 2 in back and add the y equals, we're going to have 7 over x minus 3 plus 2. Okay, so that's exactly what we did. So the new part is just the long division, which you already did. Okay, so now we are going to figure out what h and k are. We're going to draw the asymptotes, so we'll do that first. All right, so what is h? 3, good job. So now we have x equals 3. And then what is k? Good, 2. So now we have y equals 2. Right? So if you can do the rest all by yourself, go for it. That will save you a few hours. All right, so we have x equals 3 right here. And then we have y equals 2 as our other asymptote. Okay. And we want to pick 2 points to the left of 3 and 2 points to the right of 3. So if you can do this all by your lonesome, go for it. If not, we can do this together. All right. All right. So we want 2 points to the left of 3. So it really doesn't matter what I pick. Let's see, I could pick 2, and I also could pick 1. All right, so when I plug in 2, I have 7 divided by 2 minus 3 plus 2. So don't forget about that plus 2. All right, so when I simplify that, I get 2 minus 3 is -1, so I get 7 divided by -1 plus 2. And 7 divided by -1 is -7 plus 2 is -5. And then when I plug in 1, let's see, I'm going to have 7 and then 1 minus 3 plus 2, which is equal to 7 over -2 plus 2, right? Which I can't simplify 7 over 2, so I can get a common denominator by doing 2 over 1 and then multiplying by 2 over 2. So that's going to be the same thing as 7 over -2 plus 4 over 2. And then the negative can go in the middle or up top. That's okay too. So I'll change that to -7. And if you have a question right there, write it down. But we have the same name of 2, and then -7 over 4 is -3, so -1.5. All right, so that was my 2 points to the left. Now I want 2 points to the right, so I could pick something like 4. 4 would be a good one. I could also pick 5. I could pick 6, 7, as long as they're 2 points to the right. So when I plug in 4, I'm going to get 7, and then 4 minus 3 plus 2. So that's the same thing as 7 over 1 plus 2, which is the same thing as 9. And then for 5, it's going to be a fraction, which is okay. I have 5 minus 3 plus 2 is equal to 7 halves plus 2. Okay, so please make sure you're doing this work. It's not going to make very much sense if you shortcut this. So we have 7 over 2 plus 4 halves, and that's the same thing as 11 halves, which if you like decimals, it's about 5.5. Okay, so when we go back to when we go to graph this, let's see, we're not going to have a lot of room there, but that's okay. All right, so when I got 2, when I plugged in 2, I got -5, so down here. When I plugged in 1, I got -1.5. Okay, so there's 2 points, and then my graph gets really, really close to the asymptotes. So there's one branch. The next one, it is 4, 9. So here's 4, 9 is like way up here. And then when I plugged in 5, I got 5.5. So 5.5, probably right about here. Okay. Oh. All right, so this is going to get really, really close to that asymptote and really close to this one. Oops. All right, and it's going to go that way, but I ran out of room. Okay. All right, so then our last step is domain and range. So our domain is going to be all real numbers except x equals, what was h again? Yep, 3. And our range is all real numbers except, what was k again? Yep, 2. All right, so y equals 2. Okay, so we're doing the same exact thing we've done. The only new part was the long division. So when you look at the guided practice, you're still going to do the same idea. So you're going to have x plus 3 outside, and then in the box you're going to have x minus 1. Right? So for number 5, you have 4x minus 2 outside and 2x plus 1 in the box. All right? So hopefully that will get you started on that. And I will see you guys tomorrow.